Hello everyone, welcome to this week's presentation. So my name is Gustav Mukete, Modimi Mukete. I am a graduate student at California Intercontinental University. So this week we will be exploring how to apply correlational test to a survey data. So we'll go through our agenda. So we'll have a quick 5-point agenda here. The first, we'll see a quick introduction, and we'll talk about data analysis summary. We will look at the 6 significant correlation scenarios that we found from our SPSS analysis, and then we'll talk about key takeaways, and I'll give an opportunity for questions and answers. If you have any questions at the end of the session, you can post the questions or you can shoot me an email and I will be able to respond back to you within 24 hours maximum. We'll begin with an introduction here. The purpose of this correlation analysis is to measure and to interpret the strength of a linear or a nonlinear relationship inherent in the two variables under study. So we use the PSPP statistical tool of analysis. This is a great tool. It's the first time I'm using it, but I actually enjoyed using it. It's a great tool, very easy to learn. I'm very excited to explore the tool as we proceed with our lectures or lessons. So we are assuming our alpha here to be 0.05. What is the meaning of alpha? That's a question we have to answer here. So our alpha here is the probability of rejecting the null hypothesis when it is actually true. Or in other words, the probability of making a type 1 error. And what is our decision rule here? What's our decision rule? How is it going to look like? How are we going to decide if we are accepting or rejecting the null hypothesis? So the decision rule here will be when the probability is below our level of alpha, we will reject the null hypothesis and accept our alternative. That's to say, when our p-value is below our alpha value of 0.05, we'll reject the null hypothesis and accept the alternative hypothesis. So the parameter used here to measure the correlation coefficient, as from our PSPP analysis, is the correlation coefficient of R. So it ranges from -1 to the absolute 1 value, which is also independent of units of measurement. So the strength of our relationship of R will increase as the R value approaches the absolute value of 1. That is to say, a value of 0 indicates no association or no relationship between the two variables under study. Just like I mentioned earlier, we'll use the p-value, the null hypothesis, to enable this decision-making process. So we'll move to our next slide, which is a summary of our data analyzed in PSPP statistical tool. So we analyzed 10 relationships. So we compared 10 relationships that entailed two variables. In the 10 relationships, we discovered 6 significant relationships and 4 non-significant results, I would say so. So for the purpose of this study, we'll focus on the 6 significant results. The first significant result here is the relationship that we found between income and stocks. And we'll move to the second, which is the relationship between income and savings. And the next, income and wallet. We'll talk about savings and stocks. We'll look at savings and wallet and the relationship that existed or exists between stocks and our wallet. And for the purpose of the study, again, like I mentioned earlier, we will ignore the discussion of the non-significant results. Well, we'll start here with the third segment as per our agenda, which is the discussion based on the first sample, which is income versus stocks. So our hypothesis test number one will focus on this correlational test between income and stocks. So our null hypothesis here signified by H0 or H subscript 0 is stating that there is no correlation between the income and the stocks that an individual owns. So our R here is equal to 0, while our HA or H subscript A is saying that there is a correlation between an individual's income and their stocks owned. What is the result here? What did we find here? We found this as a significant correlation. So the correlation coefficient and its p-value were calculated here using our beautiful, easy to learn, user-friendly PSPP statistical tool of analysis. And we assumed our level of alpha to be 0.05. So what is our alpha of 0.05 telling us here? Our alpha of 0.05 here means that we accept a 5% chance of rejecting a true null hypothesis. So here, a significant correlation emerged. Our R value was 0.19 with a p-value of 0.018. So the test rejected the null hypothesis and concluded that there was a correlation between income and stocks. So our correlation coefficient here is telling us that there is a positive relationship between these two variables under study. That is to say, as one of the variables increases, the other variable increases. So when your income increases, the number of stocks you own will also increase, everything being constant. Or since we don't know the direction of causation, we can also say that when your number of stocks owned increases, your income also increases. So we'll move to our next test here, which is hypothesis test number 2 for income versus savings. Our null hypothesis here again is saying there is no correlation between an individual's income and an amount of savings. This is a very interesting one here. And the alternative hypothesis is saying there is a correlation between an individual's income and the amount of savings owned. We used the PSPP tool for this analysis as well with our alpha value of 0.05, and we saw a correlation here of 0.91 and a p-value of 0.00. So the test rejected the null hypothesis and concluded that there was a correlation on an individual's income and the amount of savings. It's quite a very strong positive correlation here. A correlation value of 0.91 is saying that there is a strong correlation between an individual's income and the individual's savings. So here there's very sufficient evidence to conclude that the relationship between income and savings is significant because the correlation coefficient is different from 0 or not equal to 0. And we see here that our p-value of 0.000 is also less than our alpha value of 0.005. This is also very, very interesting here. So we'll move to our third sample here, which is income versus wallet. So null here again is saying there is no correlation between an individual's income and the amount of cash that the individual carries in their wallet. And the alternative here is saying that there is a correlation between an individual's income and the amount of cash that the individual carries in their wallet. Again, we used our PSPP to compute our values, and we maintained our alpha value of 0.05. We saw a significant correlation here, a very strong one with an absolute value of 1.00, saying that there is a very strong relationship between the amount of money that an individual carries in their wallet and the income that they have. So our p-value here of 0.00 is also way less than our alpha value of 0.005. So by inference, it is suggesting or confirming that there is sufficient evidence to conclude that there is a strong positive relationship between the amount of money that an individual carries in their wallet and the income that an individual has. So here again, the null hypothesis was rejected in favor of the alternative hypothesis. Our fourth sample here is based on savings and stocks analysis. So what is our hypothesis here? Our H subscript 0, our null hypothesis, is saying that there is no correlation between savings and the amount of stocks that an individual owns. And our alternative hypothesis is saying that there is that correlation or that relationship between the amount of savings and the amount of stocks owned by an individual. Our great PSPP tool here gave us an R value of 0.28 and a p-value of 0.000. So here again, we have to reject the null hypothesis because our p-value is less than our level of alpha. Therefore, the test rejected the null hypothesis, and we are concluding here that there is a positive relationship between savings and the amount of stocks owned. In other words, when your savings increase, there is a high probability that your stocks will also increase. Or when your stocks in hand increase, the savings that you have in your credit union or whatever bank account you have will also increase, although we cannot tell how a change in one of these variables affects how a degree of change or the extent of change in one of these variables affects the extent of change in the other variable. However, we have that confidence in rejecting the null hypothesis based on the results of our p-value, our correlation coefficient, and our alpha value of 0.05. The fifth sample here is based on savings and wallet. What is our hypothesis here? Our null hypothesis is also postulating that there is no correlation between the savings and the amount of cash that an individual carries in their wallet. Then we have the alternative, which is saying that there is a correlation between the savings and the amount of cash that an individual carries in their wallet. So PSPP gave us an R value here, a strong one of 0.91 and a P value of 0.00. Here again, we are saying that there is sufficient evidence to conclude that there is a strong positive correlation between the savings and the amount of cash that an individual carries in their wallet. Therefore, we are rejecting the null hypothesis. Our final test here is based on stocks and wallets. What is our null hypothesis here and what is our alternative hypothesis? So our null hypothesis here is saying there is no correlation between the number of stocks owned and the amount of cash that an individual carries in their wallet. And what is the alternative saying? On the other hand, it is saying that there is a correlation between the number of stocks owned and the amount of cash that the individual carries in their beautiful wallet. All right, so the correlation coefficient here and a p-value, we computed this using our beautiful PSPP tool, and we assume our level of alpha 0.05 as we've done with the other samples. So we found a significant correlation here with an R value of 0.19, although not as strong as the other correlation coefficients that we have seen before. We saw a p-value here of 0.017, which is also less than our alpha value of 0.05. So we also found a significant result here, and we rejected a null hypothesis and concluded that there is a correlation between the number of stocks and the amount of cash the individual carries. And the correlation here is also in the positive sense. So as the number of stocks you own increases, the amount of cash you carry in your wallet also increases. Or as the amount of cash you carry in your wallet increases, the number of stocks you own in the stock market also increases. So that's the final and the sixth significant result that we found from our PSPP analysis. We'll move now to have a look at key takeaways. So we have three key takeaways here. The first one is there is a flaw in terms of causation. So a correlation does not signify causation. We have seen in our 6 samples, significant samples above, we cannot tell which variable is causing the next. We cannot tell if a change, an increase in savings is caused by an increase in the amount of money you own in your wallet, or an increase in the amount of money you own in your wallet is caused by income or savings. So there is a significant flaw there that I wanted to bring to your attention. So that inability to signify causation is a great drawback of correlation analysis and hypothesis testing. So the next takeaway here is saying that correlation coefficient can range from -1 to absolute 1. We saw that in our analysis. With the signs and the numbers typically signifying the direction and the strength of the relationship. So moving from 0 to the positive side increases that strength of the relationship, while moving from 0 to the negative side also increases that strength or reduces the strength of the relationship. So when you're moving from 0 to negative, that strength of the relationship goes more towards the negative side. And the third key takeaway here is saying that the hypothesis testing and correlation collectively provide validity, reliability in describing relationships and making predictions despite their flaw of not being able to signify causation between variables of interest. So thanks again for watching this week's video, and I'll give you guys a chance to ask me any questions that you have, and I'll provide answers. And also feel free to email me any questions that you have with respect to this subject matter through my email gmodi@student.caluniversity.edu. I should be able to give you an answer in maximum 24 hours. Once again, thanks for watching this series of my presentation, and I wish you all a blessed day. Thank you.